Okay, let's get started. Hopefully short lecture, not lecture. I want to comment how you guys are doing and talk about how we are going to continue. Um, let me check something else here. Let's see, first one. Okay, let me share some screen here. Okay, this is from quiz number 2. Somebody that already answered the quiz. This is one of those questions that you get on my quizzes. For example, give you this question has 3 answers. This find internal angles alpha, beta, and gamma with 3 significant digits, right? I hope you guys are getting very familiar with this way of answering quizzes in my class, because I don't think I have. Do you have any other teacher that does the same like this? No, nobody. Oh, I'm unique. I don't know how they do it. I don't know how they do it, because Canvas doesn't allow you to ask 3 questions on one problem. So that's the way I find that I could do. And then look, in this case, and you have done stuff like this, but still people keep making mistakes, and I don't want you to get bad credit for this. In this problem, you see that the guy knows how to do the problem. You see, the answers are correct, but he misplaced 2 of them, right? Because he has the 342, but in the wrong place, and the 578, but in the wrong place, right? So it's very easy to make this kind of mistake in this way of doing things. So I want you guys to be very careful when you enter your answers, that don't mix them up like that. In this, like in this question, it says here, call the 3 digits corresponding to alpha AAA, beta BBB, gamma CCC, and then enter your answer as AAA BBB CCC, and the guy did AAA CCC BBB, and the computer just don't understand that and says wrong, and the computer gives you wrong 0, no credit. So please be very careful when you enter your answers, put it in the right order, right? Remember, you don't have to put the commas. The computer adds commas for the thousands. Every three positions, computer put a comma. You don't have to put those commas. You only have to put the decimal point when it is a regular answer. When I ask for only one answer, and I ask you for 3 significant digits, and it has the decimal places, for example, 3.28. Then you need the decimal place. But when I ask you for this kind of stuff, don't put any commas, any signs, no units, no commas, no periods, nothing, just the digits. Otherwise, the computer doesn't understand and give you bad answer. Another mistake that you guys make with certain frequency is that you say, for example, in this, instead of putting 342, put 324. Instead of 342, write 324, like swap digits. All of us have a little bit of dyslexia. All of us have it. So we have to be very careful at the time of putting the answer in the computer, because that happens more frequently than you think. So be very careful when you write your answers in the computer. So the computer grades your quizzes automatically, and it just goes like a train and doesn't forgive anything. So try to be very careful about that. I don't want to give you bad credit for that. If eventually, because in order for me I will have to check answer by answer to see if you made any of those mistakes. If eventually, I try to do it, but if eventually you see that your answer, you have the answer correct, but you misplaced something, let me know and I can fix it. But it's for me, it's very hard to check everybody to see if someone made a mistake. It takes too much time. So if you guys help me with that, eventually you see that you got a bad grade, but you have your answers correct because you just misplaced stuff. Let me know after you got the answer. I am giving you 3 attempts to do the quizzes. So be very careful because when you do the second attempt, the data changes. So you don't, if you suppose you do the first attempt and you write your answers and you see that some of them were wrong, some of them went right, so you want to do a second attempt, you cannot enter the answers that you put in the previous attempt because the data is going to be different in the following attempts. Make sense? So you have to do the calculations again. Because it will be, because you guys can see the right answers, right? Can you? When you are doing a quiz and you do the first attempt, when you finish the attempt, you see which answers you got right and you can see which one you got wrong, right? Anybody?
Yeah, it shows which ones we got wrong.
Right, and it shows you the right answer. I think I told Canvas to let you see the right answers after every attempt.
Yeah, I think so.
I think so. Well, I check in the other class and it's working like that. If not, let me know, because my idea is that you do your quiz, you see which one you did wrong, and so you do you do a second attempt and try to do it better. But I want to show you the answer so you know which ones you got correct, which you got not correct. So when you do the second attempt, well, you have to do all the problems again because you have to redo all the calculations because the data changes. Is that clear? All right. And I think 3 attempts should be more than enough to kind of allow me to see if you really didn't get it or if you really have got the knowledge. And I want you to use the quizzes also like a learning experience. But we have all these problems about Canvas and entering the numbers and all that stuff that is just too crazy. So nothing works in the computer like the real thing, the old-fashioned way of making the test in real paper where you can see all your steps and everything. So that's why I am convinced that we, no matter what, we are going to do the evaluations in person on campus for the 3 big evaluations that we have. Remember the 3 big ones that we have every 5 weeks, we have a big one. That one will be in campus on the room that we have designated for that on campus. Let me see what else. And that's the reason why. Okay, let's do it then. Sundays at 9 p.m. both. 9 p.m. Now we are going to the next module. We are going to start first. Oh, wait, this. I'm gonna leave this one, the one that is due this coming Sunday. I'm gonna leave it the way it is because, well, that was set up like that for a long time. So this one, let's keep it like that at midnight on Sunday. This Sunday, they are due at midnight. I hate to make those changes on the run. So that one will be at midnight. But I encourage you guys, please don't submit that stuff at midnight because you will be in the risk that not me being able to help you. Understood? Is that understood? Kevin?
Yes.
All right.
Yes.
All right. All right. Okay, now, so let's start with that for the following homework, which is homework number 3 and quiz number 3. So they will be due Sunday, September 19 at 9 p.m. All right. If you have a problem, a question, you have some doubts about anything, you contact me by text message or by email, better by text message, so we can do a Zoom session to explain in person whatever topic you need. And we are going to meet in person next Wednesday. So 1 week from today, we're going to meet in person for whoever wants me to give you more explanation. But I want you to go there on Wednesday after watching the videos. For that day, you should have watched the ones corresponding to class number 4. All right, class number 4. Only the first section of the 3 sections that I'm going to post. You should see the first video in order to go to the class on campus this coming Wednesday. Yeah, so that will be the video that corresponds to today. So from today to next week, you should be able to watch that video. If you have questions or any doubt about the material covered in this topic of rectangular components of a force, the first class of this module 2, then come to the class on next Wednesday. I will put an announcement before that so everybody knows exactly what to expect. What else? Did you say the questions for the exams are pulled from the quizzes? No, it's going to be similar. The questions on the evaluations are similar to what you have on the homework or on the quizzes, but it's not like I choose them from the homework or from the quizzes, but they are similar. Okay, let's go for what I wanted to do here. And in homework number 2, problem 7, let me put it here. Let's see if I can show you here. Okay, this is one of the problems in the homework. If you already did it, great. If not, well, doesn't matter. I will be working with this. I will be helping you with this. So in this problem, you have one force of 450 at 60 degrees from the x positive. This is the x positive. And 715 degrees down from the x negative, right? Remember that point? I want you guys to go with me on this. Remember this problem, anybody? Okay, so you have to calculate the resultant here, right? And we are going to use basically, like if you have not seen the videos, well, this will help you understand the videos better. And if you already saw the videos, well, you will know very well what I'm talking about. Basically, in the videos, we explain 2 graphical methods to find the resultant of forces, the summation of 2 forces. So the one of the methods is the parallelogram and the other is the triangle. So for example, we are going to use the method of the parallelogram to add the summation of these forces. Let's call these forces A and B. So what you do is that you, in the method of the parallelograms, you put both vectors attached from the tail. Well, maybe this is too big. Who is arriving at this time? Let's say this is A, and then this is B. Once you have those 2 vectors, the train of those 2 vectors attached by the tail, then you have to draw parallels. On the tip of the vectors, you draw parallels to the other vectors. So at the tip of vector A, I draw a parallel to vector B, right? And at the tip of vector B, I draw a parallel to vector A. Remember that? And then the resultant or the summation of vectors A and B is the vector that goes from the place where you have both tails of the original vectors, that's the tail of the resultant, and the tip of the resultant is where the parallels meet. So this one will be the resultant. All right, very simple. That's how you calculate R. Okay, everybody agree? Now, if you do a very nice diagram with a scale and a circular protractor, or you have a nice software like the one that I have here that you can put the degrees, right? You see the degrees and you have some kind of a scale here. You could just measure the magnitude of the vector using your scale and the angle using the ruler, right? But that's not what we do. We usually do a very nice diagram and then you do mathematical calculations to find the actual real values. That's how we do it nowadays. So let me now explain the other method really quickly. The other method is the triangle method, where you draw your first vector. You draw your first vector. Let's put it here. You draw your vector A. Let's put it here, your vector A. Draw your vector A. And then too big. And then next to vector A, you put vector B. It doesn't matter what order you do it, but I put A first, and then now I put B after A. What does it mean after? It means at the head of A, you put the tail of B. So this would be B here, and then at the head of A, I put the tail of B, and I draw B like that. So this will be vector B. And then the resultant of the summation of vector A and B is the vector that results from drawing a vector with the tail at the tail of the first vector and the head at the head of the second vector. This will be vector R. And it doesn't matter which method you use, you get the same one. This vector is exactly the same as this one. All right? Okay, so basically what you have is a triangle, either this triangle or this triangle or this triangle. Any of those triangles will give you the same result. And the way to calculate the actual numbers, the magnitude and angle, is to use the cosine law and the sine law, right? So for example, and the sine law and the cosine law are no other than methods of calculating properties of a triangle. When you don't have all of them, you have, for example, a couple of sides and an angle, then you get the other elements of the triangle using these equations. For example, here you can use the cosine law to get R based on B and A. So you know this law, R squared equals A squared plus B squared minus 2AB cosine of the angle between A and B. So let's put them here. This is 450, which I call A, and this is B, 700. If, for example, I am using this triangle here, then I will have to use this angle. Somebody can tell me what is this angle here? This one? Let's call it alpha. Somebody can tell me what is that angle alpha?
145.
Okay, I'm gonna put here 450. 450. What is that angle? I heard someone say something. There are many ways to find that information, right? Many ways. Let's put this auxiliary line here. With that line, I know that, for example, this angle is This angle is 15, right? And 75?
Yeah.
Oh, let me
45.
see. 40, someone said 45, someone said 75. Let me
Oh,
put
sorry.
it
Yeah. 45.
45. I guess
Probably.
I guess so, because if I put this line 90 degrees here, if I put these lines 90 degrees here, I have 60 here, 30 here, right? 30 here, right? Okay.
Why do
And
you
so
have
that
30
would
there?
be
Why do you have
What?
30? I said, why do you have 30 there?
because I have this triangle here. Let's finish this triangle here. So I have this triangle here that has 60 here, 90 here. So this one has to be 30 because all the angles within one triangle have to add up to 180, right? So 180 minus 90 minus 60. So 180 minus 150, 30, right? So this is 30. Agree? Okay. Okay, let me write that. All right, so everybody agrees that alpha is 45? 45? Everybody?
How did you get the 15-degree angle on top?
Okay, this angle is the same as this one, right? Because this line is parallel to this line, and this is horizontal, and this is horizontal. So those angles are the same. All right?
Okay, thank you. Yes.
You're welcome. You're quite welcome. Okay, so that comes to the conclusion that that angle is 45. 45. Can somebody find, please, R? R, anybody? I have 30 engineers in front of me. Let's see how many resultants we get here. Oh, 195? No, what is that? No, what is that? Oh, where are we? What is 195? R is 195? Anybody else got 195? Let me put the numbers here. A is 450. 450. 450 square plus 700 square minus 2. 450. 700 cosine 45. Okay. Oh, the square root of that, right? The square root of that to the 1/2. Okay. 497. 497. My drawing is kind of well done. Let's see what we get here using my ruler. 1, 2, 3, 4, 5, 6, 7. I don't know why. Okay. So if that's 700, then the resultant according to my scale here is 1, 2, 3, 4, 490 something. Yeah, so this looks good. I like it. See, I did a check with my graph. Okay, so we agree 497. Now let's get the angle.
Why is it cosine 45?
Sorry? What was the question?
Why is it cosine for? Why do we use cosine 45?
Why we use cosine of 45? That's the question? Is that the question? Hello?
Yes.
Oh, remember the
Yeah.
line of cosines. We say R is equal to once. Let's put it here. R 450, 700, and 45. So this square is this square plus this square minus 2 times this cosine of this, the angle that is in front of the one that you want to find. All right. Remember we discussed somewhere that is the same Pythagorean theorem, right? This one.
I just didn't see why we used 45, but I see.
What? What was the problem?
I just didn't see why we used the 45, but I see it now.
Okay. Remember that the cosine law is like a particular case of the Pythagorean theorem is a particular case of the cosine law. You are trying to get C, which is in front of the 90-degree angle. Cosine of 90 is 0, right? So that's why this doesn't, and you end up with this. So basically you are trying to get an angle by using the other, a side of the triangle based on the other two sides and the angle between those two sides that you know. So here the angle is 45 degrees. I don't know, I put 450. Here is 45 degrees. Okay, now let's calculate the angle. The question in the problem the question says, determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. So they are asking for this angle. This angle. So we are going to find this angle, which is part of our triangle, and then we add 60 degrees, right? If you agree. We're going to add that angle and we add 60 degrees. That angle, let's call it beta. The orange is beta. So the angle that they are asking is 60 plus beta. Let me erase all this stuff. Let me erase all this stuff here. Okay, how do you find that? What law you use to find that? What law you use to find that? Anybody? Which law?
Sine law.
The sine law. The sine law. What will be the good way to set up? Let me help you here. I want to do everything here. I would do 700 over sine beta like R over sine 45. Would you do that? Agree? My third engineers. Okay, I see somebody doing like this. I like that. Thank you, Darcy. All right. That's the way I will do it. Anybody use another method? Okay, if I do that, I get that beta is equal to sine minus 1 of 700 sine 45 divided by R. R is 497.01 or something. Somebody says something like that, right? 497. Let's do 5 significant digits in all intermediate calculations. Let me do it here really quickly. Square plus 700 square minus 2 times 450 times 700 times cosine 45. Right, square root of answer. 497.01. Okay. What did you get if you do this? What do you get if you do that? 700 times sine 45 divided by answer. This is 0.99587. Well, 958 from 59. 59 0.
And 84.8 degrees.
Actually, this is sine beta.
Did anyone else get 1.2? Or is that just me?
What?
I got 1.2.
For what? For beta or for sine of beta?
Did you do 497 divided by 700?
No, I did 700 times sine 45 divided by 497.01.
And then you get what?
I got 1.2. But
For this operation here?
yeah, it may be just the
Let me do it again.
setting.
700 times sine 45 divided
Are
by
you in radians or degrees?
7.01. I got 0.9959. Yeah, check if your calculator is in radians. That happens.
Yeah, I thought it was in degrees, but it was in radians. Sorry about that.
Yeah, okay. No, that happens all the time. Be very careful. Be very careful because the quizzes are merciless. Okay, and if you do the arc, which sine is 0.99590, what do you get?
84.8.
84.8. 84.8. Well, the actual answer, we have beta, but the answer is actually 60 plus beta. That's the actual answer. It's 60 plus 84.8. So this is equal to 144.8. 145. But the answer that I give you is 155. Anybody got 155? Nobody? This is the actual answer. 155. What did we do wrong here? Anybody? What? This is the actual answer. What do you think we did wrong? But you were following here, and if you watch the video and follow that's what it is. You get the triangle. You get the triangle, making your graph. You calculate R using the cosine law, which we did here, and some of you verified. And then we did the sine law that we can make an error with the radian thing on the calculator, but we fix it, and everybody agreed that there was this number and this number. So no error, no error. Well, I'm gonna tell you what happens here. The answer is 155 because look, the angle that we were looking for was this angle, the orange angle. Let me clean this a little, so we can see it better. Okay. The angle that we were finding was this one. And we get 84.8, 85. We got 85. Does it look 85? I don't know how big you have this in your computer there. Let me put it very big. I check the scale. The art gave me, like, according to my scale, was pretty good, the 497. And I measured these angles here. Look, 60 degrees. Huh? Am I precise or what? You see it? How about this one? Look. Can you do any better? I'm very proud about my sketch. And then this is R. I did my parallels with my ruler. I am so happy with my ruler here, electronic ruler. Look, 15, perfectly parallel. My 60 degrees. perfectly parallel. And then when I measure, this is not 84. This is not 84. It's more than 90. Look, if I have here 60, then 90 will be, if I measure 30 here, look, that's 90 degrees. So my angle is more than 90, right? So it cannot be 84. So the only way you can see that we made a mistake, that 84 doesn't look right, is by looking at a graph well done. That's another reason why I want to insist. Good sketches are very important because they give you the key to finding the right answer. Now I'm going to tell you why and how you can calculate the right answer. Here, looking at a graph, at a sketch that is well done, you have a hint that your answer is not right. It's not 85 degrees. It's not 84 point something. The problem with this is that when you calculate sine, let's do this here. When you have this, let's say you have this angle here. This angle, the sine of this angle is equal to this value, let's call it opposite side, divided by the hypotenuse of that triangle, right? And let's say this is beta here, beta. So sine of beta is equal to opposite side over hypotenuse, right? But if I draw this angle here, like this, I have now this angle here all the way like this, which sine is this distance, which is the same distance O, and this is the same hypotenuse. So let's call this angle alpha. The sine of alpha here is equal to O over H, and the sine of beta is also O over H. So those two angles have the same sign, right? So that's what happened here. We got the sine is 0.9958, and we look for the angle which sine is 4.9958, and we found this one, but we were looking for this one. And since both have the same sign, how can we know which one is the good one? By looking at a graph that is well done. There is no other way to know that the right answer is not 85, but 95. Is not 80. Well, and this is 84.4 is actually 95.2. So the way you get that is because the problem is that your calculator gives you the angle on the first quadrant. So if you want to get the other angle that is on the second quadrant, you have to do 180 minus 84.8. So that's how you get the 95.2. And the actual answer then, remember, it was 60 plus beta. 60 plus 95.2 equals to 60 plus 95.2, 155. The right answer to the problem. And there is no other way to catch that problem if you don't have a very good sketch, a very good diagram of your problem. Make sense? I want you guys to be aware of that. I don't think I'm gonna give you a problem with this little, this ugly problem like that. But if you get something like that, you have to check always your answers in a way, in any, like in an alternative way, to have some idea if what you're doing is right. A good professor, one of my best teachers when I took my undergraduate program, he used to tell you should never do a problem if you don't know the answer. Only do problems if you know the answer. So what he was meaning is you should try to get the answer to your problem somehow, at least like an approximation before you do the actual real exact answer or calculation. So when you get the right answer, you can compare with your approximation that you did from some other method to make sure that your calculations make sense and are correct. So here we have the answer in the diagram. The diagram is telling us the answer. We just have to get a circular protractor and measure the angle, or I can do it here by saying this is 25. Sometimes this happens. So I wanted to discuss this little problem with you guys to have you guys make aware that that happens with the sign that we are doing using these low signs with, but you encounter that problem more often that you would think. So be careful. I will try not to put something like this in the quiz. All right. Okay, too much about that. Any questions? Any questions about this? Can we leave it like that? No more questions? Okay, I think that's all I have for today. Let's see if there's anything else here.